Have you ever actually stopped to think about where your trading robot stores its memories? Seriously, when your automated algorithm calculates a moving average or counts the number of open positions, or even just tracks the time of your last trade, how exactly does it remember that data from one tick of the market to the next? Well, the answer lies in variables. They're literally the fundamental building blocks of your system's memory.
Welcome to this explainer on MQL5 variables. Today, we're diving deep into the MetaQuotes Language 5 reference to uncover exactly how your trading robot manages its internal memory. We're going to be looking at scopes, life cycles, and the behind-the-scenes memory management that really separates a clunky, slow script from a sleek, high-frequency, professional expert advisor.
Here's our roadmap for today. We'll kick things off with MQL5 variables and scope, then move into standard, local, and global variables, check out the power of static variables, dive into user-facing input parameters, and finally wrap up with memory, life cycles, and deinitialization. Okay, let's jump right into part 1, MQL5 variables and scope. So a variable's scope strictly defines where in your code it can actually be seen, accessed, and modified. You can kind of think of it like a security clearance level inside your program. If you declare a variable inside a specific block of code, let's say inside a loop or a specific mathematical function, it is totally locked to that block. The source material points out something really interesting here. If you have nested blocks and a variable in an outside block has the exact same name as one in an internal block, the outside one is actually temporarily hidden while that internal block runs. It's a super strict scoping system, but it's absolutely crucial because it prevents accidental interference and keeps all your calculations pristine. Moving right along to part 2, standard, local, and global variables. Now, there's this massive divide in standard MQL5 memory. On one side, you have local variables. These are essentially temporary scratch pads. They completely die the second a function finishes its job. On the other side, you have global variables, which are permanent vaults that you can access from anywhere in your program. But hey, you really need to be careful not to confuse standard globals with terminal global variables. Terminal variables are on a whole other level. They're shared across the entire MetaTrader 5 platform, which means different robots can literally talk to each other. You'll use functions like GlobalVariableSet to write data, GlobalVariableGet to read it, and GlobalVariableCheck to just see if a variable even exists. The absolute secret weapon here, though, is GlobalVariableSetOnCondition. It acts like a traffic light, creating a semaphore system so your different programs don't step on each other's toes when they're managing shared resources. Oh, and if you only need data for the current session, just use GlobalVariableTemp. Or if you need to survive a sudden power outage, you can use GlobalVariablesFlush to forcefully save everything straight to your hard disk. All right, section 3, the power of static variables. Now ask yourself this. How exactly do you make a local function remember its own past? Let's say you've got a function that counts trades. If you use a standard local variable, well, it just resets to 0 every single time the function runs. You could use a global variable, sure, but recklessly exposing a variable globally completely breaks the rules of secure scoping we just talked about. So we need a hybrid. Here is the magic trick, the static specifier. By just dropping the word static right in front of your local variable declaration, you literally change its underlying physics. The MQL5 compiler takes that variable and stashes it away in the global memory pool. That means it exists from the exact moment your program boots up, and it actually retains its value between function calls. But because it was declared locally, it stays completely invisible and protected from the rest of your program. It is the absolute perfect blend of local security and global memory retention. On to part 4. User-facing input parameters. So input variables. These are external parameters defined with the input modifier, and they're brilliant because they essentially act as your program's external settings. Now, inside your MQL5 code, these variables are strictly read-only. Your robot absolutely cannot change them while it's running. They can only be modified by the user before the program starts up. This is great because it lets traders tweak things like moving average periods or lot sizes without ever having to dig into or recompile the actual source code. The coolest part is that the moment you declare an input variable, the MetaTrader 5 terminal automatically grabs it and builds out a properties window. It completely transforms your abstract code into a clean, clickable user interface. You can even use enumerations, like creating a drop-down list for days of the week or different moving average smoothing methods, just to make the whole interface incredibly user-friendly.
Now, here's where it gets really interesting for professional development. You've got the static input keyword, which stands for static input. This lets the user still change the variable, but the strategy tester will completely ignore it during optimizations. That is fantastic for visual settings or debug toggles that you definitely don't want slowing down your massive optimization runs. On top of that, you can use the input group keyword. This lets you visually organize massive lists of parameters into neat, named, collapsible blocks right in the UI, which makes complex expert advisors so much easier for your clients to actually navigate.
And finally, Part 5, Memory, Life Cycles, and Deinitialization. We definitely need to talk about where these variables physically live. As the source text outlines, local variables are automatically placed on something called the stack. The stack is a super fast, highly efficient, fixed-size memory area. To put numbers to it, custom indicators get 1 megabyte of stack memory, while expert advisors and scripts get 8 megabytes by default. On the flip side, when you build complex objects or arrays on the fly using the new operator, those go into dynamic memory. Dynamic memory is requested directly from the operating system. But here is the massive catch. Unlike stack variables that just clean themselves up automatically, dynamically allocated memory must be explicitly deleted by you using the delete operator. When you do, it's immediately returned to the system. But if you forget, you get memory leaks.
It all really boils down to a few essential rules. Global variables initialize the second the program loads, and they deinitialize in the exact reverse order right before it unloads. Local variables only initialize when the execution actually hits their specific line of code, and they die the moment the program exits their specific block. And dynamically created objects, they are completely independent. They initialize only when you explicitly call new, triggering their constructor, and they deinitialize only when you call delete, triggering their destructor. You are in total control, which means, you bear total responsibility.
So the next time you sit down to build a custom indicator or an expert advisor, I want you to ask yourself a pretty critical question. Are your variables just taking up unnecessary space, living way too long, or worse, leaking memory? Or are you actively using strict scoping, smart static variables, and cross-program terminal globals to build a memory management system that is just as sharp and efficient as your trading strategy itself? The tools are all right there in the MQL5 reference. Now it's completely up to you to use them.